Okay, here's Bill and Jane again, each on the terminator line but opposite sides of the ball Earth. Looking perfectly horizontally, the sun is so huge that they can each see virtually half of it geometrically. But neither can see the thin black line in the center because it is blocked by the Earth. But dip angle allows Bill to see a little below his perfectly horizontal horizon, and so once we apply that, he can see an entire half of the sun. Notice that he can't yet see the peak new moon though. Now, since we are only interested in the exact center of the sun, it doesn't matter how large it is. So at this point, I'm going to make this easier to see by zooming in and shrinking the sun. So here's Bill with his horizon line a mere 2/1000ths of a degree below perfectly horizontal. And he can see exactly half of the sun now. His horizon line is bisecting the sun, cutting it perfectly in half. Is his horizon line also bisecting the peak new moon right now, so that he is seeing exactly half of the sun and exactly half of the moon on his horizon? Of course not. But if Bill's horizon was perfectly bisecting both sun and moon, and this particular peak new moon happened to be eclipsing the sun, then Bill would be seeing something like this right now. Both sun and moon cut perfectly in half by his horizon. And this is exactly what I'm looking for. This is the entire point of this entire angle series. Now I know we can see this sight a couple of hours before peak new and a couple of hours after peak new. I'm waiting for you globe believers to either explain how we could see this at the precise moment of peak new moon, or openly admit that we can only see it a couple of hours before or after peak new. So please tell me, how do we get to that perfectly bisected eclipsed sunrise or sunset from here? Well, you say that if Bill is standing up, the dip angle is 4/100ths of a degree, and I've only given him 2/1000ths of a degree. Okay, let's give him the full 4/100ths then. Oops, that can't be the answer. We've already lost the game because Bill can now see more than half of the sun, but still isn't seeing any of the moon. And we need him to be seeing exactly half of the sun and half of the moon, right? What if we send Bill up in a high altitude weather balloon to increase the angle he can see around the ball Earth? Okay, well now he's seeing some of the moon, but he's a full sun diameter off the sun now. And we need Bill to see exactly half of the sun and exactly half of the peak new moon at the same time, remember? I know. Let's appeal to refraction. That seems to fix a lot of other ball Earth observational problems, right? So let's refract the moon up to where Bill can finally see exactly half of it from his weather balloon. Oh no, not again. Yep, if we apply refraction to the moon to fix the problem, then we also have to apply at least as much to the sun, right? And by the time we add enough angular and refractive help to allow Bill to finally see exactly half of the peak new moon on his horizon, the sun will be 3.2 sun diameters away from him seeing exactly half of it on his horizon at the same time. So now I'm stuck and I need the ball Earthers' help. I can't for the life of me figure out how to get exactly half of the sun and exactly half of the peak new moon on Bill's horizon at the same time. On the other hand, YouTube has quite a few videos showing eclipsed sunrises about 2 hours before peak new and eclipsed sunsets about 2 hours after peak new. This one was 2 hours and 26 minutes after peak new. This one from Guthrie, Oklahoma was 1 hour and 50 minutes after peak new. This one from Australia was 2 hours and 6 minutes before peak new. Anyway, I think you guys get the idea. I'm just looking for a way the sun and the peak new moon can rise or set together in your model. Is it possible or not? I say it's not possible because the moon can't possibly be directly between the middle of the sun and the middle of the earth at the same time it's between the middle of the sun and the terminator line on earth. If you have a way it can happen, please say so. If you don't, then just openly admit that it cannot happen.